Hello, my name is David Butts, and as a former tutor on the module, I have been asked by the module team to record some brief supporting material for some of the key underpinning maths concepts. These are covered in study notes in the main material, and the purpose of these recordings is to offer an alternative approach if you need further help. This is the first of the recordings and supports the study note after SAQ 3.1 in Block 1, Part 3. Why are percentages and parts per million used? The answer is for making comparisons. For example, if 392 people in one village of 719 inhabitants were in favour of a wind turbine development, and 571 out of 1,048 in another village were in favour, how is it possible to compare these two cases in absolute terms? The way to do this is to work out how many villages in each 100, that is percent, are in favour. To do this, the data is first of all expressed as a fraction, 392 divided by 719, and then multiplied by 100. So 392 times 719 times 100 equals 54.5%, and the percent symbol denotes that the value is indeed a percentage. Stop the file at this point and have a go at working out the percentage of those in favour of the wind turbine development in the second village. Here is the answer. 571 divided by 1,048 times by 100, and that is 54.5%. So the percentages are the same, and this shows the value of expressing the data like this, as this equivalence was certainly not apparent at the outset. I can now pick up the study note after SAQ 3.1 in Block 1, Part 3 of the module material. As indicated earlier, percentages and parts per million are used to indicate proportions of numerical quantities. Percentages show the number of parts out of 100, and as the name implies, parts per million represent the number of parts out of a million, that is 1 followed by 6 zeros. For example, 30% is 30 out of 100, and 65.2 is 65.2 out of 100. Stop the recording and think of ways of displaying data like this. Where the data has an integer value, such as 30, then there are a variety of ways of displaying it, such as this one. You may often see part shading of a figure or star, but these lack precision. Where this is needed, a pie chart is often used. In a pie chart, the full circle of 360 degrees represents 100%, and the different proportions which make up the whole are denoted by coloured segments. Parts per million, ppm, is useful for smaller proportions, such as a carbon dioxide concentration in the atmosphere. Here, the Keeling curve from Part 1, Section 3.1 of Block 1 is shown. The vertical axis is carbon dioxide concentration in parts per million by volume. Please note, incidentally, that getting the details correct is important in scientific communication. So when you write carbon dioxide, make sure that it is C, uppercase for carbon, O, uppercase for oxygen, and subscript 2, denoting 2 oxygen atoms for every carbon. Don't write C0 subscript 2 or CO2 with the 2 not subscript, or CO2 with the 2 as a superscript.